Previously, I took a look at the Rohde and Schwarz MXO4. Since then, I've used it almost every day, except for the past few months because they sent me their even newer MXO5. In this video, we'll look at what's new with the MXO5, compare it to the 4, and talk about some new capabilities found in both. By the way, if you are not in the market for this class of oscilloscope, I hope your inner measurement nerd enjoys seeing what they can do. Rohde and Schwarz provided the equipment used in this video. The MXO5 has up to 2 GHz of bandwidth and samples up to 5 gigasamples per second, with 500 megapoints of memory standard on each channel. Now, the maximum acquisition memory depends on the channel count and if you're using single or continuous triggers. There are 4 and 8 channel models available, and unlike some scopes, the 8-channel MXO can power 8 active probes at the same time. The analog to digital converters are natively 12-bit, but using HD mode, you can trade off bandwidth for up to 18 bits. The front panel screen is 15.6 inches and has a resolution of 1920 by 1080. It has ports for HDMI and DisplayPort. On the back is the optional 2-channel arbitrary waveform generator, and on the front are the ports for the 16 digital channels. If you need to move the scope in and out of a secure environment, the SSD is easily removable. So, who needs the MXO5 then? Well, the obvious answer is anyone that needs 8 analog channels. For example, if you're measuring 3-phase motors or power converters, you can measure the voltage and current on multiple phases at the same time. But that's not a measurement that I make very often. Or ever. However, I did give 8 channels a try on a retro computing project. Here, I simultaneously measured all of the clocks and video signals in my Mega 2E computer. Like the MXO4, even with 8 channels, HD mode, and measurements turned on, the MXO5 remained responsive and updated fast. That performance is why scopes in this class have so many digits in their price. Now, one thing I did find annoying is the collars that are used to identify probes. RNS only provides 4 colors for the passive probes, so I found myself adding doubles to differentiate which probe was connected to which channel. By the way, if you pay attention to any video where I'm doing stuff with scopes, I almost never match the probe color to the channel color. When the MXO4 came out, I did a very long video going over its many unique capabilities, and almost all of those apply to the MXO5, so I'm not going to repeat everything here. However, if you want to learn more about these scopes, check out that full in-depth video. In summary, the MXO oscilloscopes are unique because they have what RNS calls the MXO Extreme Processing ASIC. It contains the digital trigger system, which is some of the most precise triggers on an oscilloscope. It can do waveform math at a rate of millions of waveforms per second. It processes some of the fastest FFTs I have ever seen. It can even apply digital filtering on a channel-by-channel basis, and it does a ton of other things. It's the key reason why the MXO can capture up to 4.5 million waveforms per second. Just to clarify, those functions happen in real time during acquisition. It isn't like some scopes that tack on an FPGA to help process the data after it's been captured. Since I am not keeping this scope, and I had a minor mishap when I took apart the MXO4, I'm not going to tear this one down. However, inside the 8-channel MXO5, there are 2 of the MXO-EP ASICs and 4 ADCs. You get full sample rate on channels 1 through 4, or 5 through 8, or by alternating channels. Just make sure you watch which channel is using the trigger. And that's because the trigger system is looking at the digital data to find the event of interest. So even if you're not displaying a channel, it still has to be sampled in order for the trigger to work. Let's go take a look at some other things that the ASIC can do that are really fast. For example, the update rate is really fast with 1 channel, but if we turn on 3 more channels, the update rate still stays above 4 million waveforms per second. It isn't until we add a 5th channel that it drops to 1 million, and 6, 7, or 8 channels drops to 500,000 waveforms per second. By the way, that is still ridiculously fast, and it isn't a special mode. Now, let's go see what happens when we start using waveform math. With channels 1, 3, 6, and 8 turned on, we're at 4 million acquisitions per second, like we'd expect. Turning on math to add channels 1 and 6, it drops to 1.3 million acquisitions per second. Using a second math function, if we add channels 3 and 8, the acquisition rate stays 1.3 million per second. However, if math involving channels 1 and 3 are used, the scope drops down to 6,000 waveforms per second. So why is that? It's not because I'm using 3 math functions. It's some combination of math across channels and how the MXO-EP ASICs are getting used. Because if I only do 1 math function on channels 1 and 3, then the update rate is still only about 6,000 per second, which makes me think that the top 4 and bottom 4 channels are handled by different ASICs. And no, I don't consider that to be a severe limitation, but it is one of those details to keep in mind as you get into more complicated measurements. Okay, if we're talking about fast and math, we need to talk about FFTs. When I looked at the MXO4, it could only do one FFT or spectrum channel. On the MXO5, a single spectrum achieves 46,000 FFTs per second. And as the tabs imply, the MXO5 can do 4 of these. The scope maintains 46,000 FFTs per second even when turning on a second spectrum channel. It's not until we add a third or fourth that it drops to about 23,000 FFTs per second. Two things. For an oscilloscope, even 23,000 FFTs per second is really fast. And two, since the MXO ASIC does the heavy lifting, there's one more trick that we can do. If I back up and do math on channels 1 plus 2, and then do a spectrum of that math function, the update rate is 33,000 times per second. And for fun, enabling the HD mode causes it to drop just a little bit. That's all happening inside of the ASIC, which is why it's so fast. I mean, this update rate and overall performance is why I like the MXO series so much. It is just so fast. By the way, RNS did tell me that there is a software update coming for the MXO4 that should increase its spectrum count to 4 as well. Speaking of new features, here's a couple more. In a previous video, I covered a feature called the measurement track. This tool creates a waveform based on a measurement's value. That means for each period of this sine wave, the track creates a period measurement. The x-axis is the time interval for that measurement. The y-axis is the measurement value. So if we zoom the time base out, you can see there is a modulation on this sine wave. A frequency measurement on the track waveform shows its frequency to be 1 kHz, which matches the settings in the arbitrary waveform generator. Another enhancement is the math editor. Now it lets you create arbitrary math functions as equations. If you use the editor on the RNS RTO or RTP oscilloscopes, this UI will be somewhat familiar. It is super powerful, and as cool as it is, I could not really think of a great example yet. So maybe you have an idea of something I could try, and then I could share it in a future video. Let me know if you have any ideas in the comments. Also, RNS continues to expand the supported serial decodes and triggers. Which brings me to something that I missed on the MXO4 and almost missed on the 5. It's called dual path protocol analysis. For this example, I have a busy screen. The top grid is the full capture of the analog signal. Below that is the serial decode of that analog signal. And below that is a zoomed view of the decoder. Over on the right is a table showing the decoded packets. The device under test is an Arduino Uno R4 transmitting a very long message over UART. On almost every other oscilloscope I've ever used, if you start aliasing the analog signal, the protocol decoder will stop working. But watch as I drop the sample rate to 1 kilosamples per second, which is far below the signal's data rate. In fact, the analog waveform is destroyed. There are only 1 or 2 wiggles on the analog side during the entire serial decode, which is working without any problem. And that's because the MXO ASIC detects the edges at full sample rate while decimating the sample data for the analog display. And here's the thing, that's been in there since day one, I just didn't realize it because it works so well. Now, when I did the MXO4 video, I did make fun of the zone trigger button because it does nothing. However, on the MXO5, annoyingly, it still does nothing. I have heard a rumor that might change in the very near future, so stay tuned. For now, let's recap. The MXO5 offers up to 8 channels and 2 GHz of bandwidth and maintains an industry-leading waveform update rate. It can do hardware-accelerated math or multiple channels of spectrum analysis. Obviously, I think the MXO5 is a great oscilloscope. I also believe that Rohde and Schwarz is leading this segment with incredible performance and innovation. But that's what I think. Let me know what you think in the comments below.